Did you know that the same chemical process that adds flavor to food during cooking occurs inside your body? In this process, sugar molecules fuse with nearby amino acids, the building blocks of proteins, to form new substances. In food science, we call this the Maillard reaction. When this same reaction occurs in the human body, it's called glycation. Hi, I'm Dr. Maria Conley, and today I'd like to talk about how the same browning reaction that occurs during cooking takes place in the human body all the time. In glycation, the fusion of a sugar molecule to a protein in the body often causes irreversible damage to that protein. These damaged and dysfunctional proteins, called advanced glycation end products or AGEs, accumulate in the body with age. Diabetes accelerates the process of glycation as the high levels of sugar or glucose in the blood make it even more likely that sugar molecules will combine and collide with proteins. In 1912, Louis Camille Maillard discovered how sugar molecules combine with amino acids in protein-containing foods such as meats, nuts, cereals, and vegetables. The oven temperature must be 284 degrees Fahrenheit before sugar and amino acid molecules have enough energy to react together. Remember, heat equals energy. So the more heat you have, the more energy the molecules have, and the more reactions they're going to have together. So at this temperature, 284 degrees Fahrenheit, the Maillard reaction begins to occur, causing browning of food and creating new flavors. The reactions accelerate and peak at approximately 320 degrees Fahrenheit. The same process actually occurs in your body, which can be seen as a low temperature oven, typically set between 98 degrees Fahrenheit and 99 degrees Fahrenheit. Glycation is a primary mechanism of human aging, and it occurs at an accelerated rate in older individuals and in those with diabetes. Glycation is just one of the spontaneous modifications that can affect proteins in your body. It is happening all the time, and it doesn't even require an enzyme to occur. In the body, glycation typically involves a sugar such as glucose or fructose combining with a free amino acid group on a protein. Some of the proteins most affected are those that come in direct contact with blood, including proteins like hemoglobin, immunoglobulins, insulin, low-density lipoprotein or LDL, and collagen. So, what's one example of a glycated protein? Well, in 1955, researchers discovered glycated hemoglobin, the first human protein known to be modified by glycation. And then in 1968, it was recognized that a specific glycated hemoglobin, known as hemoglobin A1C, was elevated in the blood of diabetics. Today, we use hemoglobin A1C as a marker of how well diabetes is controlled. A higher level of glycated hemoglobin in the body typically indicates a higher average blood glucose level over the previous 2 to 3 months. This is the average lifespan of a red blood cell containing hemoglobin proteins. Your body is usually able to repair or dispose of these modified proteins or AGEs but not always. The greatest accumulation of AGEs occurs in long-lived proteins such as collagen and elastin in the walls of arteries, crystallins in the lens of the eye, and myelin proteins insulating nerve fibers. Glycation of these proteins makes them less elastic, less dissolvable in water, and less digestible by enzymes. In other words, it's hard to get rid of them as they build up in your body. AGEs can form crosslinks and can cause progressive stiffening of tissues in the body that are rich in these long-lived proteins. For example, cross-linked collagen and elastin make the walls of arteries become more thick and stiff and less elastic with age. These thickened arterial walls don't work as well, causing diseases such as hypertension and kidney disease over time. We call this the glycation theory of aging, a process which is accelerated in diabetes. In diabetes, the excess glucose molecules in the blood are toxic to the arteries, particularly those that carry oxygen to the eyes, kidneys, and nerves. Many of the proteins in your body actually act as enzymes, which allow necessary reactions to occur in your body. However, when a sugar molecule attaches to a protein during glycation, the structure of the protein is altered and it can no longer function properly as an enzyme. So it can't do its job. In short, glycation is one molecular mechanism that explains normal aging as well as conditions of accelerated aging like diabetes. High blood sugar levels are slowly toxic to your body over time, causing aging and disease. Thank you for listening. I hope that this was helpful for you.